Hello, I am Hyperdev and welcome to the Infinite Runner tutorial. The first thing that you're going to need, of course, is Unreal Engine 5. And this tutorial has been updated to work with basically any Unreal Engine 5 version. Even the earlier versions, it will work the same way. Now, in order to get the animations, there's going to be one other application that you should have available on standby, which is going to be Cascadeur. Now, you're going to need Cascadeur to make the animations, so I highly recommend getting it. It's entirely and totally free. But I will also include animations with the project for those that are not animation inclined, and it will give you a good starting point. Now, with that out of the way, make sure you get that done, and then we're going to create the project. Now, once you launch Unreal Engine, you're going to have the option to create a project from simulation to automotive, architecture, video, and of course, games, which is what we want. Now, for this project, to really learn proper game development, do not start with any of these, initialized projects. Simply select blank. You're going to make a blank project. Then you're going to select the location of the project and the project name. Now, I am simply going to call it glider, but you can call it whatever it is that you want. And then as far as project defaults, default it to Blueprint. Target platform, you can choose between desktop or mobile. It only adjusts some of the settings for visuals. If your PC is a bit on the slower end, I recommend set the target platform to mobile. That will ask Unreal Engine to set it up so the graphics are a bit lower and it's going to be easier to make. If you have high performance, set it to desktop. And then, of course, quality preset, I just set it up at maximum. And with that, you simply head over and you hit create the project. Actually, one moment. Let me call this Infinite Runner glider. Okay, perfect. And then create the project. Now, this is what you're going to see when you start up Unreal Engine. I am going to have my mouse on screen so you can see what I'm doing with my mouse. Now, if you simply hold the right click and drag, you can look around so we can see the entire environment. We'll get into how to interact with the engine a bit later, but for now we're setting up. The first thing is this right here is not going to be the level we want to be in. What we have here is simply the base level with this Unreal Engine blank project. Okay. Now, what we really want, I have my keyboard showing on screen, is we want to head over to file and we want to hit new level. Okay. After hitting new level, it gives you some options: open world, empty, basic, or empty level. Okay. Simply select basic and create. Now we have created a simple level. I am holding right click and S to zoom out and to move backwards, basically like zooming out. So now we have a big open level and then a simple rectangle over here. That's going to be all we need to get started. The next thing I highly recommend is we're going to come over and then press Ctrl and S. That's going to attempt to save. Now notice it has brought up a window. So save level as. I'm going to select content. I'm going to create a new folder and I'm going to call this folder levels because it's good to keep good organization when you're doing game development. I'll double click in levels and then I'm going to save this as runner map. That's all I'm going to save it as, and then save. So now we have the runner map saved as our level. And now we want to set this map that we've created as the default starter map. So you would head over to edit, and then you want to hit project settings. Now within the project settings, let's go over to maps and mods. And then there is a section where it shows the default maps. So right now there is one called editor startup map. You want to select it and go from open world to runner map. Since we've saved it, it's available to select. And then we want to hit default map of the game, and same thing, runner map. So now every time we open up Unreal Engine, it's going to immediately default to this starter map that we've selected. Hit Control and S to do a quick save of everything in the project. And the last little step we're going to do is we're going to go over to the editor once again, select plugins, and then up here you're going to type telemetry. Okay, now there is editor telemetry and studio telemetry. And what you want to do is you basically want, yes, to simply disable studio telemetry and editor telemetry. And the reason why we are disabling them is that they are a pretty big performance hog in Unreal Engine. So removing them is going to make it simpler and less, how do we call it, stuttery, and there'll be less performance dips when we are doing our game development. And then you'll be asked to restart engine. Simply click over and click on restart, and let's move forward. Now in the next video, we're going to get started with the project. And now let's go in and have one last look. So I've pressed F8. I'm zooming out. So notice that the player character stops right over here. Now the reason they're stopping right over there is simply because when we spawn in this platform of 5,000 units, actually 10,000 units in length in total, it's causing the next platform to spawn and start from around here because it spawns in the middle of the next item. So what we're going to do is we're going to adjust the platform spawn to be 5,000 units further ahead. Now to do that, it's pretty simple. We'll go into base platform and we'll go to the code where it spawns the next platform. And then what we're going to do is first break that link, and we want to split this structure pin and split the structure pin here. That's just by left clicking. And what we'll do is that, let's see, the challenge is coming from X location. Okay, so what we're going to do is we're going to connect the Y location directly, the Z location directly, and then we're going to get the X location, and then we're going to add an add node, okay, to add distance, and then we're going to type 5,000 units. That's going to move it forward by 5,000 units and connect it to the X. Now that we are done with setting that up, let's go and see what it looks like in game. So I'm going to hit play and then F8 just to quickly see. Yeah, nice. Now the platform is being spawned 5,000 units ahead, and the box is going to be hit much later. That is good. Now that we have that out of the way, we've moved forward the position of the spawning. Let's go back to the base platform. Now, we know for a fact that inside of the base platform, we've set it up that the box spawns in over here. That's what's going on. However, we want the box to be able to spawn in 3 different positions. And we can set it up so that sometimes it spawns in the middle, okay? Sometimes it spawns in the top area, and sometimes it spawns in the bottom area. So that's really what we want it to do and how we want it to work according to our plan. Now, the really simple way to implement that is by saying, hey, we know that its world position, its world location is being managed right over here on event begin play. So what we are going to do is we're going to come over here and we're going to make there 3 different locations it can spawn to. So let me put this over here, zoom out a bit. I'm actually going to move this way up over here. Okay, cool. Make sure I move all the nodes because it's going to take up some good amount of space. Push this up. So we have the first location it can spawn to over here, which is the exact middle. But we're going to make some adjustments. We're going to get this spawn actor node, copy and paste it down here. And then what we're going to do is we're going to get the world location, okay, this one over here, and then we're going to drag it out and connect it to the transform location of the second node. And then we're going to copy and paste this and put it way down here. Man, this is getting pretty huge, okay? We're going to need to keep really organized to make sure this works effectively. Let me actually bring this down over here. And then we're going to drag this down here. Now we need to make it random which of these positions it ends up connecting to. And then we're going to need to split up this pin and make adjustments to which position, or rather the placement of where the object spawns in. Now, let's start with the first thing, which is we're going to come over here and we're going to first break all of the links because we know there are 3 positions it can spawn in. So connecting it to the first position, let's first split that and then split this as well. Now, the one change we're going to make, let's go into the viewport, spawn obstacle 1 location. Let's see if I move it up. I can move it up, let's say about 200 units. I can move it down 200 units, and that's all along the y-axis. Good. So we'll select the y-axis, the value y, drag it out, and then we'll say add. Okay. Actually, yes, we'll add exactly 200 units, and then we'll leave the x as is, we'll connect the y, and then we'll leave the z exactly as is. And with just that, if we compile and we press play, let's see, now it has moved the object, the block, 200 units to the right. That's good, that's working correctly. Next, let me push this up. Okay, let's move this up over here. Now for the next one, we'll split it and open it up. We will connect the x as usual. We will connect the y as usual. And we'll connect the z as usual and the y as usual. So in the middle right here, if it connects to this, then all it's going to do is it's going to spawn in the middle, which is good. But what we're going to do now is we're going to get out the y, drag it out, and then we're going to subtract. And after subtracting, we are going to subtract only 200 units. Now that we have subtracted 200 units, we're going to go down to the final node, the final position. Oh, sorry, why did I promote that to a variable? Split that up, and that's going to be where the y is, because there are 3 positions. Then I connect the z to the z, and I'll connect the x to the x. So fundamentally, we are getting the world location from there, and we are only making adjustments to its y position. Well, yes, its position along the y-axis to move it slightly to the left or to the right of the player. Now we need to randomize which node it goes to. Now to make it random, all we have to do is add in a node known as a branch on integer, or rather switch on integer. So we type switch on int, and here it is. It's called switch on int. Basically, it's going to switch depending on the integer it's fed. Now, going to add three places it's going to switch to. So on 0, it will connect over here to the first type. Let me break that upper link. So let me actually zoom out, because this is quite a bit. Let me grab all of these and push them forward to give more space. So we have our switch on int, and we'll connect it to the rest of our event begin play. Now we're going to connect 0 to the first spawn location. We're going to connect 1 to the second spawn location, which probably also needs some additional space because it's getting cramped. Let me space it a bit more. Okay, yeah, that's more than enough space now. And then we shall connect the switch on 2, okay, the 2 to the final location. And with just that, it can now randomly go to these places, but we need to give it a random input. So what we're going to do is we're going to type random int. So what it's going to do is this is going to output a random integer, and its max value is going to be 2. So now that its max value is 2, I'm going to insert this over here, Control S. Now let's zoom out. Hit compile, go back to the map, and let's do a quick test. I've hit F8 to come out. So that time over there, it spawned it to the right. The second time, randomly, it has spawned it in the middle. Actually, to test this properly, let's go to obstacle type 1, select the cube, type in collision, okay, and we're going to set the collision to no collision, okay, so that it doesn't collide with anything. Now hit play. So in the first time, it got stuck in the middle. The second time, it is on the right side. Excellent. And then it spawns in the third. Man, this is kind of slow, but okay, let's go. Third time on the right side. Okay, good. Now I'm going back to the base platform. I'm going to change the output from a max of 2 to a max of 3. And then I'm going to add a second pin to the output, because there is a likelihood that actually it's not spitting out 0 since it's set to random. So I'm going to drag this out, and the default is both 1 default and 0 will send it to the first position, but then 2 is going to send it to the second position, and then 3 is going to send it to the third position. Now, just for the sake of my sanity, I'm going to go to the player blueprint, zoom out, and I'm going to go to the movement direction. I'm going to turn that up to 4 just to speed up the movement of the player so we can test how the spawning is working properly. So F8, I've zoomed out. Okay, so the first time it spawned in the middle. Second time it spawned on the right. It keeps moving forward. Okay, oh my goodness, this is still too slow. Spawned on the right again. It's still too slow. Let me increase that speed to, legitimately, I'm going to increase it to 16 because we need to test this out really fast. Okay, so much faster. Okay, spawned on the right first time, spawned on the right second time. Now it's going to keep moving. Spawned in the middle again, and then keep moving. Let's see one more time. If it doesn't spawn anything on the left side, that means we're going to need to make another adjustment to the code. Keep going, keep going, keep going, it keeps going. Yeah, it's spawning too often on the same side. Let's make an adjustment to it. So we're going to go back to the base platform and we're going to make an adjustment to the integer. So instead of using a random integer of max 3, let's switch that up. So we want random integer, but this time we want a random integer in a specific range. So we'll start from a minimum of 1 and then have a maximum of 3 to indicate the 3 positions and set up the output over there. I've hit save, Control S, compile, select the player, and I'm going to legitimately increase the speed to 36 just so that we can check this quickly. Okay, so the back, let's see, it started out on the left, that's good. The next spawn, it has spawned on the right side, that is good. Let's see if it can spawn something in the middle. Okay, let's go. Nice, not bad at all, in the middle. So that shows that now with this setup, it's able to spawn in these obstacles correctly. That's pretty good. We can stop there for now. Next, we are going to make an adjustment to make sure that that code works for multiple different positions, because of course it's not going to spawn in one object then you move for a distance. We want the spawns to be a bit tighter. We'll set up more positions and test out spawning from there. All right, so now we simply need to increase the number of places where our spawns are happening. Our spawns coming in middle, to the left and to the right are 100% locked in. Now let's adjust and add in more positions where the spawns can happen. Now to do this, we're going to go back inside of Unreal Engine, and what we want to do is we want to transform our code, our nodes, this one over here, spawning obstacles, and we want to transform these into a function which we can keep recalling. Let's go through what that means. But before then, we'll go back into the viewport and we'll select the first position, obstacle 1. Going to copy it and paste it. Okay, so there it is. We have a second position. And this one, I'm going to adjust its location to be negative 4,500. That's probably too close. Let's make it 4,000 rather than negative 4,000. So we'll set it up. So that's spawn obstacle 1. Spawn obstacle 2 is set up over there. Okay. And then I'll copy and paste and add another one. So 3 will be negative 3,000 units. Okay. Notice that we are setting up the positions. I'll do the same thing for a fourth position. Okay. and this will be negative 2000. Okay, nice. And I'll just keep doing that because I want to set up lots of different, hold up. Hey. Okay, so the fifth is going to be, let's see, we have the fourth is at negative 2000. The fifth is going to be at negative 1000. Okay, and then, we'll add in another. So I'll copy the fifth, I'll paste it. So that's the sixth, and that's going to be at 0. So that's going to be smack dab in the middle. 7 is going to be positive 1000. And then the eighth is going to be at positive 2000 units. Okay. And then last but definitely not least is going to be the ninth, is going to be positive 3000 units. Actually, we could actually add in a quick 10th, which is going to be positive 4000 units. So now, let me quickly compile. Okay, bring this down. Let's see, default scene root is good. I want to organize these properly. So we have our spawn self, that's the plane. Okay, so I'm going to add in all the spawn positions and I'm going to drop them into the plane so that all of them are under the plane. And not physically under, but in terms of like their organization. Actually, it might be smarter to simply leave the spawn positions outside and not put them under anything. So here we are, we have all our different spawn positions. Each one is 1000 units ahead of the other. And now that we have all those spawn areas set up, let's go into the event graph. Now what we want to do is we want to have this spawn obstacle 1 deleted because we don't need the spawn obstacle. We need a specific position based off whichever position is selected. So let's quickly delete that, and then what we're going to do is we're going to come over here. Let's actually also select that string and delete it. We don't need it anymore. The code has proven itself. And then we're going to get all of this, mark it, okay? And then we want to collapse to function, right over here. So let's collapse that to a function. And now all of that code is now just this. Now that we've collapsed all that code into this small function over here, let's name the function. So on the left side under functions, there's this one called new function. I've pressed F2 just to change its name. And we're going to call this spawn position. That's just the name of the function. It's called spawn position. So now we have this that spawns the position. And if I double click it, you can notice that it has an in and it doesn't have an out. Basically, it terminates from here, which is cool. Now, what we're going to do is on the spawn position input node, we're going to select it. And after selecting it, if you look at the right side under properties, it's going to be able to accept inputs. So what we really want is we're going to select the spawn position. And when it comes to its input, we want the input to be a vector. So a vector is basically X, Y, and Z position. Okay. And that's pretty cool. So what we're going to do, now that we have it as a vector, we can simply come over, select spawn obstacle 1 and drag it in, and then connect it to the drag this out, then get world location. After we get the world location, what we want to do is we want to connect it to the position. Okay. Now that we have that, let's go into the spawn position. Now we have the position coming out over here, and all we're going to do is want to split it up, and we can basically break this. Now, since you followed step by step, the remainder of the logic should really make sense to you. So we'll simply get the X and we'll connect it to all of the different X coordinates, okay? We'll keep it simple like that because the X positions are the same no matter what. And the Z position will connect it the exact same way as well for all the 3 locations it's going to be spawned into. Connect them there. And then the special one is going to be the Y. We'll connect the Y over here for the first one, connect it directly because it's plus 200 units on the first position. And then we'll connect the Y to the negative 200 units for the final position. And just like that, this is all the code for spawning in the object in all the 3 different positions. And then we'll set it up and organize it nice and neatly. Nice and neatly. And voila. Now we have this function, and keep in mind, remember it's a function, so we can quite easily reuse it. So what we're going to do is, now that we have the spawn position working appropriately over here with this, we now want to set it up so that we can have this happening multiple times. Now, this is what that's going to look like. We're going to have, let's start by testing out the first one. I'm dragging the event begin play node right up over here, and then I'm going to drag that out, and it's meant to, let's drag this out here. It's now meant to work once. So let's compile. There are no compilation errors. Go back into the runner map, press play, F8 to come out so we can see what's going on. There it spawned on the left. Here it spawned on the left again. Nice. Now if we go back to the base platform, we can see that all this code is working appropriately. Now there we did that using a function. Now we're going to set this up as a macro. Let me show you what that means. The difference between a function and a macro is that a function is consistent and it works the same way no matter where you put it. A macro is different, it's not consistent. So let's do this quickly. Now to make this macro, we want to leave the target and spawn obstacle is going to be out, but we will have spawn position and get world location all together. So I'll select those two, I'll right click, and then I'm going to come down to collapse to macro, and there it is, and that's the new macro. Okay, and we don't really need to do anything special with this macro. We don't need to call it anything really. We understand what it is. And then come over here and let me first break this link. And if I come up here and I call spawn obstacle 3 and I connect this over here and compile, this should work as intended. Head into the runner map, press play, F8. Yes, now it's spawning in at position 3, which is perfect, perfect, perfect. Now we shall go back to the base platform. Since we have a macro set up, what we are now going to do is we're going to drag out from the event begin play, okay, and we are going to type the word sequence. and that is going to create a sequence node. And the sequence node essentially is just going to keep doing something over and over, like it will go through 1, then 2, then 3. So let's quickly add these in. We need 9 of these sequences in order for this to work correctly. Now that we have 9, let me delete obstacle 3. So the first thing it does is that it's going to do that for obstacle 1. Let me just copy this, and then I'm going to quickly paste this. So copy paste, that's 2, copy paste, that's 3. We'll do it 4 times, 5 times, 6 times, 7 times, and 8 times. So those are 8 copy pastes. And then let me come over here, delete all the obstacle ones, and just make sure that all of these are connected and hooked up. So that's the first, second, third, and fourth. The fifth, go through. The sixth one, I need 2 more. That's 7. I need 2 more of these macros. So 1 and 2. So let's line that up. Boom and boom. Done. Now with all of this set up, it's only the first position that's set up correctly. That's spawn obstacle 1, but we're going to correct that. I'm putting in position number 2, so that should work effectively. Let me put in position number 3 as well. Let's link that up over there. And then come down. It's basically just setting these up. Position 4. That's good. No, organize that there. Let's see, 5. We've set that up. And then 6. Set that up nicely. And then we have 3 more. Oh, back to the event graph, please. I need to put in 7, 8, and 9. So 7, 8. Connect that. Actually, 9 and 10, there are 2 more. So then select 9. Oh, 9. Boom. And then last but not least, 10. Select and connect that. And with all of these connected, let's first do some cleaning and organization. I'm going to select all of those, right click, and I need to straighten all pin connections. Oh, that's not working effectively. Okay. Select the nodes to begin with, and then select alignment, align all of them to the left, and then right click that again, and then distribute vertically. Okay, that organizes them. And then I'll select these, and then I'm going to straighten all. Actually, what I want to do is I want to select all of these, and then select alignment. No, I'll leave that there. Even if it's a bit disorganized, this will be fine. Let me not put my desire to organize everything. Let me speed this up. So now that we have all of these, they should be working. Let me hit compile. If we go into the map now, notice that there are now objects spawned in all these different areas. So there we are. So now our player character, when they move forward, all these objects will spawn in. So let's keep going. Come on, and then spawn in the next. Boom, there we go. So, and they are spawned in different positions. Sometimes they are spawned in to the left, sometimes they are spawned in to the right. So it kind of keeps everything in a nice orderly fashion, as you can see. Okay, but keep in mind, right now the spawns are entirely random. So in reality, the player, for lack of a better word, rarely needs to move to the left and right. Okay, so we need to just adjust the spawn slightly. Hold on, let's look at it from the player camera. Oh, left and right. Oh, that's not great. So next we're going to adjust the positions and the balance of where things spawn in and have it so that the player has an adjusted camera that shows it more of what's in front. Let's go. All right, so our spawn in code is working correctly. But we have a bit of a challenge. Every single time the game starts, it immediately starts spawning in objects, even on the very first platform that the player is in. So we want to set it up so that it only spawns from the second platform onwards. The way we're going to do that is we're going to set up a big collision over here that listens in for if it touches the player. If it touches the player, it doesn't spawn in anything. If it doesn't touch the player, no problem, it will allow all of the objects to spawn in. Now that we know we're going to do that, what we are going to do is go into the base platform blueprint. Now inside of the base platform blueprint, we shall simply go over to components and we want to add a component and we want to add collision, and let's add a quick box collision, and we are going to call the box collision player check because it simply wants to check for if the player is here, and you can see the box collision over here. Now this box collision is quite small right now, so I'm going to select its scale and I'm going to increase it. Let me lock its scale. Okay, I've locked its scale, and then I'm going to increase its scale to, let's say, about 10 on everything. Much better. This is a much more visible collider. Now I'm going to unlock its scale, and on the x-axis I'm going to scale it to about 30. 30 is not enough. Let's scale it to 50. So in this entire region over here, it's going to be able to check for the player and see if the player is going to be on the platform. Let's look at what that looks like in the real world. Nice. So this is going to first check and see if the player is here. Now keep in mind there are many ways to do this. This is just one simple logical way to do it. So we have this collider. The next thing we're going to do, now this next part is actually really simple to do. So what you want to do is get the player check, and you want to quickly add an event and call it event begin overlap. Now it's spawned in that event, but like kind of low. I want to take it much higher. Okay. And what we're going to do is we're going to completely replace the event begin play, because we don't want to spawn in on begin play. We want to spawn in if we detect that the player has not been hit. And then for the other actor, we are going to type in cast to player, which is basically saying, hey, is the player anywhere inside of the vicinity? And if the player is inside the vicinity, simply print out. Okay, let's print out the string, and it's going to be simply player detected. Okay, it will just print out that string, player detected. If the cast fails, in other words, the player is not there, it's going to spawn in the obstacles. Now, with just that setup, we save and we quickly compile. So let's go back into the map. Notice that, look over there, absolutely no spawns. But then right after that, for the second one, the player is able to spawn into the world. Look at that. So now that we have this working correctly, let's move forward. The next thing we're going to optimize is we're going to go into obstacle type 1. Obstacle type 1 is, of course, the obstacle over there. And then the very first thing we're going to do is we're going to drag out from it. We're going to add a quick delay, and crossing over the platform shouldn't take too long. So let's say 20 seconds, and then destroy actor, which is going to cause it to destroy itself. We compile, and now let's have a look at how it's looking. I'm zooming out. I've pressed F8 to zoom out. So it is working correctly here. It is not accepting to spawn in obstacles, but for the next platforms after the first, it is correctly spawning in obstacles. And it's continuing to spawn in obstacles. And then I'm looking in the back right after a certain amount of time, the obstacles despawn, which is just 20 seconds. So the back one despawns on collision, but the objects despawn after a certain amount of time. Let's have a look at it. Okay, that's too quick. Let's change the amount of time from 20 seconds. Let's increase it to, let's say 30 seconds. 30 seconds should be enough time for the player to pass the object from when it's created, but then for it to not spend too long inside of memory. Because if too many objects stay in memory, then it's going to cause problems, because someone can run out of RAM, and that's just poor optimization. So let's look at it from the bird's eye view, of course using the mouse and WASD. So the player object is right over there. It keeps moving forward. It despawns the back, good. And then after 30 seconds, those go away. That's good. At this point, we have the spawning in reasonably optimized, and we have our player character moving forward. Now, in the next video, we're going to make some alterations to the spawning in code, because you can notice that sometimes it spawns in many objects on the left, which is perhaps not what we want. And we're noticing instances where it's spawning in two objects, including one in the middle. We're going to look into the code and do some general bug fixing and adjustments. Let's move forward. Okay, so now that we have the spawning in code working pretty correctly, let's make some adjustments to the player camera so that we can see more of how the spawns are going. So we'll simply select the camera, and then we're going to increase its vertical position. And then actually, let's way increase its vertical position. That's about 40 units. Move it much further back, about 400 units. And then we're going to adjust its rotation. Okay, not on that's the wrong axis. Yes, want to adjust its y-axis rotation, and maybe give it about negative 15 degrees. 15 may be many, maybe negative 10. Okay, just negative 10 over there on the y-axis. So quickly compile. I think this is a much better camera for an infinite runner. I'm hoping that you agree. Okay, so there we can actually see what's happening, and we can see the things that have spawned in ahead. You can always keep making adjustments until it's something that you like. Jumping over that object, come over here, jump over that object, jump over that object. Not too bad. Okay, so now that we can clearly see what's ahead, let's make another little adjustment. We're going to select the player, and as far as the world direction velocity, I'm going to increase that to about 4. But more than that, right now we are speed limited by the character movement, asset. Now, right now its max acceleration is set to 2048, and it also has a maximum walk speed. So let's type in walk here because we want to look for it. So right now its maximum walk speed is set to 600. I'm going to increase its maximum walk speed to 3000 and save. And what I'm going to do is compile. Okay, so now you can notice that it's able to move forward a lot faster, which is leading to a lot more spawns, which is good. Now, of course, this is probably kind of not tenable speeds. Come over here. Now, after much testing, I think I've settled on what would be a good speed to start with. I think at this speed, it's reasonable and we can get started working on the other elements in the game. So the speed that I have chosen, let me quickly head over to the player, check out its blueprint. Now, under the character movement component, I have set the max walk speed to 2000 centimeters per second, which I think is perfect and should work at least for the baseline as we start developing the other parts of the game. So next up, we're going to get into now changing all the different obstacles that the player character is going to find once they get into the world. So now let's go in. We have the good baseline and add in some more life and spice to the game. Let's continue learning in the next video. Now, the first thing that we are going to do is to plan out the infinite runner. Now, planning means that we're going to figure out what it is we're going to set up and do during the course of the project. Now, the thing that I use for planning is Affinity Designer. You don't have to use this. You can actually use pen and paper or whatever software you like, but the fundamentals are the same. First things first, I don't like being eye blasted. Let's get a black background in there. Now, black backgrounds for planning are the best. It really reduces eye strain and fatigue. All right. Now, the very first thing we need is we need a player. That we know is what we need. We need a single player character. Now, with the player, to make a good infinite runner, the player needs to be able to do 3 things under their control and 1 thing automatically. The player moves forward automatically. From game start, it starts running forward. The player needs to be able to jump up to avoid low obstacles. The player needs to be able to slide or go under certain obstacles that are high. And then the player needs to move left and right, but the player needs to be lane limited. That's what makes a pretty solid infinite runner. Now, the next thing we need is to know that the player is locked into 3 positions, okay? So the player can either be at position 1, that's the left, position 2, that's the middle, and position 3, which is a bit more to the right. This is how we call these lanes in terms of an infinite runner. So there is the left lane, the middle, and the right lane. And that's why I say, hey, the movement is left and right, but it's lane limited. So when we go into creating the game, the limits of the lanes will be respected. Now, the player needs to jump and slide. Why do they need to jump? It's because of obstacles. Now, when it comes to obstacles, there are really only going to be 3 types that we're going to make. There is the low obstacle, which requires the player to jump. This is a bit small and short, but that's just to show that the solution to this is for the player to jump up. Then we have the high obstacle, which means it will hit the player's head if the player just runs into it. But this high obstacle is there to encourage the player to slide. The slide movement lowers the profile of the player character. And then there is the full obstacle. I've placed it here, but it would really be in one of the lanes. The full obstacle needs the player to change its position in the lane. So when it's there, it can't jump over it, it's too tall. The player must either move to lane 1 or 3 based off what it sees is ahead. Now with that, this is really the general overall game plan for a simple infinite runner in 3D. If this makes sense, we can now move forward and get into Unreal Engine. Now that the general game plan is outlined, it's now time to put it to work. So we're going to make a simple player, add it to the world, and get it moving forward when the game starts up. So when you are inside of Unreal Engine, I am going to right click and use W. Basically, what's the controls to move forward like in a shooting game. And I'm moving to the center of the world. This right here, this point is 0, 0, 0. It is the center of the world. Now let me zoom out a little bit. And as you can see, we are inside of a space with a large box, rectangular box here as a platform. So I'm going to move towards the platform, and around here at 000 is where we want to create our player character. Now to create it is very simple. If you press Control and space bar, Unreal Engine is going to bring up the ability for you to access all the files, right? Now let me zoom in. Remember the levels file we created? Here it is, and the runner map is there. Now we're going to create another folder. Now the reason why we are creating this folder is simple. It is because we want to keep it organized. So I've created a new folder by right clicking, and then we are going to call this the player. It's going to be very simple. I'm double clicking on the player, and now we are inside of the player folder, and we are going to create a new blueprint. So right clicking again, going over and select blueprint class. After selecting the blueprint class, what we really want is a character. Now, there are a variety of blueprint classes we can use that contain functions to manipulate objects in Unreal Engine, but the one we want now is the character. So I've clicked on character, and now it wants to give it a name, and we'll call it player, just for the sake of simplicity. After that, Control and S to save everything, and double click on the player. Now that you've double clicked on the player, notice that we have a few objects inside. There is, on the left side, you're going to be able to see what's inside. There is a capsule component, a character movement component, a character mesh, a skeletal mesh component, and a simple arrow component. Now to start with, all we want is to get this player and drop it into the world. So let me quickly drag this. When I'm dragging it, and I'm dragging that to the main window because it opened that up in a different window. So now we have access to the player blueprint window and the actual level by itself. So what we'll do is we'll press Control and spacebar again. That's going to bring up our folder. I'll simply select the player, and I'm going to drag it and drop it into the world. Now notice that our player is there in the world at a specific position. Let's set it up so that it's positioned at 0, 0, essentially, but we won't change its height, otherwise it would start entering the ground. Okay, so come over to details. Okay, the details, select the details, and then notice that there is location. Let's set location on the x-axis to 0. That has moved the player slightly vertically. And then on the y-axis to 0 as well. Now the player is literally in the middle of the world. I won't change its height, that is the z-axis. I won't change its height, otherwise it would start entering the world. Now if we press play right now, absolutely nothing happens. Literally, we are still in developer mode and can float around. The reason why is because we haven't set it up to connect to the player when the game starts. So let's first go to the player, and we want to add a simple box just so that we can see where it is position wise. So we're going to add a simple cube. That cube is going to be perfectly fine. Let me just After selecting that, right, after adding in the cube, we're simply going to go over and adjust its scale. I think its Z scale could be increased. Yes, right up until the height. So I've just increased its scale on the Z. I just right click and then I go up or down. So now that cube is about the same height as the cylinder. So now if we go in game, it's right here. So this is our current player character. Okay. I've pressed escape to come out. And now that we have the player character over here, let's now attach something to the player character so that when the game starts, we connect with the player character. To start with, we want to add a camera to the player character. So we'll head over to add, and the first thing that we want to add is we want to add what is called an arm, okay, a spring arm. So we simply add a spring arm. I do not want it to be added to the cube. Let me drag it out. I want it to be connected to the capsule component, okay. So we now have a spring arm. This right here, that line is the spring arm. Simply select the spring arm and then click on add. And this time, what we want to add is a camera. So I've selected the spring arm, I've added in the camera. And now if we go back into the level, we aren't yet connected to it, but around here on this object is a camera at its back. Okay. Now the next thing we're going to do to make sure that we attach to the player object is we're going to simply, hold on, let me get out of that. Select the player object. Notice when we click it, it's showing the camera right over there. I'm going to hide my mouse just so that you have absolute clarity. So you can see that the camera that we just added is now showing one face of that little cube we created. Now, if we select that and then we head over to details, we're going to now scroll down into details. And what we want to look for is to possess. Now, the possess basically means that it takes over. You can take over it. Now, I've scrolled and notice after collision presets, we come down a little further. And there is now the option of, hey, auto possess AI or auto possess player. Now we can simply select player 0, which is going to be the main player in a single player game, and then zoom out. And this time, when we press play to start playing the level in the editor, there we are. Now we are connected to the player. But if I try to press anything on my keyboard, nothing happens. I press anything on the mouse, nothing happens. And that's okay because we haven't set up any controls. I don't think you can hear me. I don't think you can hear me pressing buttons. But let me turn on my keyboard and my mouse. Now I've hit play. Notice I'm pressing anything and nothing's coming out. I'm wiggling my mouse around. I'm pressing, nothing is happening. We haven't set any of that up. But if you're seeing this, that means you're setting up the character correctly. Next, let's make it so that the character, immediately the game starts, it begins moving in a forward direction. Now to do that, we are going to go to the player blueprint. So now we are inside of the player blueprint, and inside of the blueprint, we want to head over to the event graph. The event graph is where all the code of the player is going to basically exist. Now, the one thing that we want to look for is known as the event tick. So the event tick is a very simple node. It really fundamentally does one thing. It fires off every single frame. So basically every single frame every time the physics in the world is being calculated, the event tick is going to do something. So here's like a really simple example. If I press right click and type print, and I'm going to say, hey, print a string, and I connect it over here, it's going to print out hello. Okay, so we can compile that, press play. So notice on the right side, every frame it's printing out hello. Let me stop. Now, how about I connect the delta seconds into the string so that it prints out the delta seconds from when the game starts. Compile, come over here, press play. So now notice it's showing the difference in between the frames. So every 0.008 seconds, it is going to be printing out that value. So that's the frame time. So let's stop, come over here. Now, from the tick, instead of having it print something, we want it to actually move forward. So what we're going to do is we're going to add a movement node right over here. Now the input we're going to use, simply right click, and we want to add movement, hold on, add movement input, that's over here. So we want to add a simple movement input, and we want to add an X location movement input. The reason why is because notice that red arrow over there. That means that moving this block forward is going to be on the X axis. Since it's on the X axis, we're going to simply add in a movement input on the X. Let's connect these two. And then on the X, let's simply say 2. While direction, we'll get the vector of 2. That's the size of the movement. Compile, and then hit play. And now we have our block that's moving forward in a straight line. This is the start of our infinite runner. I'm pressing escape. Now we have the basic baseline. Me click on the outliner, double click on the player to get to its position quickly. Now this is our baseline in terms of creating the infinite runner. Now in the next video, we are going to add in the movement to make sure that the character has the ability to jump as well as to move left and to move right. Let's move forward. Now let's quickly add left, right movement and jumping. So the process of doing that is going to start off with adding in some controls. Now adding in controls is a simple process. Control spacebar. Now you will notice that we have a folder called player, but for organization's sake, we are going to add in a new folder and we're going to call it controls. I think I'm going to move it out of the player and I'm going to put that into content. Okay, I want it to be within the big content folder. So there's that folder now called controls. Now to make controls, it's a simple process. You simply right click. Okay, let me make sure you can see what I'm doing with my mouse. You simply right click, you head over to input and you add in an input action. So the first input action, we are going to call it move left. All right, then we'll create another input action. We're going to call it move right. All right, and then we're going to create two more input actions. We're going to create one called jump, and then we're going to create another one and we're going to call it slide. The slide we will not use right now, but we are going to use it later. So let's quickly have a look. I'm hitting Ctrl and S to save everything actually, before moving forward, let me come up here, and Control Shift S is going to save all, just to make sure we don't lose any work. Now, if I click on, let's say, move left, it's going to show us the input. It has a couple of character descriptions. It has the description of the action, and then it has, hey, can you trigger this when paused? No. Reserve all mappings, no need, and value type digital boolean. Basically, it means that this input is an on-off switch. You don't need to do anything fancy here. I just wanted to show you what's inside here. Now I'm quickly going to close that up. Oh, yes, here. Close that and come over here. Now that we have our jump, move left, move right, and slide set up as inputs, we are now going to right click, select input, and add in an input mapping context. And I'm simply going to call this player map. Okay, that's really player input map. Okay, so there it is, player input map. Now let me quickly double click on that. And now this has a few things. It has mappings and a description. So I'll select on mapping, open this up, and right now it says none. I'll click on that, and the first one I want to map is going to be jump. Add another one. I want to then map slide. Add another, and then I want to map move left. And finally, we want to map move to the right. Now we've added in all these mappings. Now when you open it up to the drop down, you're going to be able to press a button which is going to tell Unreal Engine this button is going to be the one to use for this input. So with jump, I simply click it. I've hit space bar. I'll add a plus to add another mapping to it. So on the second one, I'll click it. I'll press W, so W will also be jump. Press it again, select that again, and then I've pressed up on the keyboard. And now, if you have a controller, you can do this on controller as well. Let me quickly attach my Xbox controller, but it should also work with a PlayStation controller. So you can see that an input device has been connected. That is my Xbox controller. Back over here, select it, and I'm guessing for jump, I just want A, which is going to be gamepad face button bottom. Okay, so now those are the controls just for jumping. Now the jumping controls are all set up. Let's now add in the sliding controls. So in order to slide, I'm going to start with S, or for WASD. Another button I want to slide is going to be down, the directional input. I think those two are enough. I think another button is perhaps shift. Shift is usually a button to pause a slide. And then another one, now on my controller, I have hit B, or gamepad face button right. Now, let me put my controller on the screen so you can see this. So, gamepad face button right is B, and on the jump, gamepad face button bottom is A on the Xbox controller, or X on PlayStation. Now that we have these inputs set up, so we're done adding in buttons for jump and slide. Now let's add in some buttons for moving left. WASD A is going to be moving left. Oh, I don't know why it's opening up all of those up. And then there is also left on the keyboard. And then there is also on the gamepad, I want to select left on the gamepad So gamepad, D-pad left, that should be enough for all of the inputs for moving left. Can close that up, and then we'll do the same thing for moving right. I simply want D for the WASD users, and then apart from D for WASD, I want right on the keyboard, and then I want for my controller right. Okay, so gamepad, D-pad right is going to be for that. Now with all of those set up, let me quickly just close these up. All of that set up, Control S to save, and now let me close that up and immediately save all. Keep saving. I recommend saving because Unreal Engine's feature of, let's say you lose electricity or anything else happens, or your PC crashes, its feature for saving all your changes is not that good. I've found it to be unreliable and I've lost a lot of work using it. But fundamentally, we have most of the controls fully mapped. So now we have jump, move left, move right, and slide all set up, and they are now set up in the player input map. Now let's make those useful. Let's go back into the player blueprint and let's call up a lot of those functions. Now, to call up the functions is pretty simple. We are going to first come and we'll start with the jump. I've just typed jump after right clicking inside here, and we should be seeing the enhanced input action event jump. That's what we want. So I'll put the jump right over there. And then we want the slide, and then the enhanced action event slide is here. So I'll drag this over here. And then we have move left. Here we are. We have move left. And then let's drop in move right. Excellent. So here we go. So now we have move right, move left, slide, and jump. We are not going to do slide in this video. So let's quickly work on the jump and the move left and move right. Now, the very first thing that we are going to do, we have created the player input mapping, but let's try something simple. Let's say every time the player presses jump, we simply print out a string saying hello, right? If we try and go into the map right now and we try to press anything, it's not going to jump. Now, the reason why it's not jumping is because we haven't added in and told Unreal Engine to use the mapping that we have selected. So go right up and look for the event begin play node. Now from here, we're going to tell Unreal Engine to use the player input map for the player character. Now, doing so is actually very straightforward. The first thing we're going to do is simply right click, and we want to get the player controller. This tells Unreal Engine to get whatever controls the player has. Next, we're going to request to cast to player controller. On. Actually, minor adjustment, we don't get the player controller. What you really want is to get the overall controller. Then we're going to we're going to cast to player controller. Okay. So now that we have cast to the player controller, we want to request the input subsystem. So we shall simply type input subsystem, and that's what we want. Get enhanced local player subsystem. And now that we've called upon the subsystem, we'll simply call from it, and then we want to add mapping context. And now that we have added a mapping context, it lets you select the asset. Of course, we'll use the player input map asset. Now let's quickly connect these two nodes. Come back over here. I'm going to use the event begin play. So let me just quickly organize these blueprints. Make sure that, let me bring them a bit closer together. All right, now that we have this, so essentially from the event begin play, we get the controller, we cast to player controller, call up the enhanced input local player subsystem, add the mapping context of the player input map, and voila, we are done. Let me quickly compile. So now when I press jump, it prints out hello, which is pretty good. So now that it is listening to the jump, let's now add in a jump right over here instead of the string. Now, in Unreal Engine, since our blueprint that we're using is a player character, it comes with a built-in character movement component, okay? So, to get a jump, all we have to do is right-click and type out jump. And now, if we connect the input action jump to the jump, we can compile that, go into the running map, hit play. You see now it's moving forward. I press spacebar and it jumps. I press W, it jumps. Okay, it's falling off the building. And then let me try on my player controller. If I press A, it does the jumping action. That's actually really good. So we have the ability to jump. Now, whenever I make jumps, I always love, let me quickly zoom out. Let's first select all of these, push them down a bit further. We'll come back to them. To make jumps better to feel, I like to always have a do once node. And then after that, go from the trigger into the do once, into the completed. And then from cancelled, I'll connect to the reset. What that does is every time the player jumps or presses jump, it's not able to jump again until it releases the button, or they release the button and then press the button again. This is an example of what that looks like. Let me quickly go into debug. So you'll notice if I press spacebar, it jumps, but it only resets. Notice right there it's set to do once, so it's not going to work, right? It's not jumping again. However, let me actually break from cancel. Let's go to completed. So the player can only jump once there. But now that I have it from completed to reset, so it restarts every time you're done pressing the button. When I press, then it resets after. Okay, so that's one of the cool ways you can use blueprints to change the game feel. Otherwise, the player would always be jumping if they're pressing down the button. Here, they have to let go and press to jump again. It makes the game feel better. Now that we have the general jumping, let's make sure it's commented. So I'm going to press C on the keyboard to bring up a comment, and then I will call this jump handling. So it has made a little comment box with the words jump handling. Personally, I prefer my comment boxes to be fully black with white text. I'll drag it out over here and then expand it. So now every single time we come into Unreal Engine, you can see this comment box and you won't need to wonder what's doing what. So we have jump handling. Let me get it. And then instead of setting it to group movement, I'll set it up as just a basic comment so that it doesn't move the nodes. I'm going to copy it, bring it right up here, move up the begin play node, and then I'm going to copy the comment and paste it out here, drag it here, and actually let me not drag it in from the begin play, let me bring it in over here, and then I'm going to double click and I'm going to call this setting up control inputs. I highly recommend every time you're doing anything in Blueprints to comment it, because that's going to make it easier to follow. Now that we have that jump, let's now add left and right movement. So I will get the slide and drag it way down. We don't need the slide at all right now. But we do need our moving left and we do need our moving right. Okay. Now, if you remember back to the plan, there are going to be 3 lanes. So there are positions 1, position 2, and position 3. So what we want is every time the player moves left or right to be limited to one of those 3 positions. Now we'll go into how to set up the limits in the next video. For now, we're only going to set up just the movement. Now to keep us focused on just the movement, I'm first going to break the link that's causing the forward movement. All right. And then up here on the debugging, just set it up so that it is debugging the player. So now when I hit play, the player isn't moving. I've just resized this window. One of the benefits of Blueprints is that you're able to do debugging in real time. So clicking in, this is perfect. Now, next, scroll down to where the movement nodes are. Now, at the node of enhanced input action left, we're going to use a simple node called move to. So we'll drag out and then we'll type out move component to. It's trying to move the component to a specific location. Now within the move component to, you will notice that it has a target relative location and rotation. We don't need to worry about the rotation. So what we're going to do is we shall simply select the relative location and split it up so that we have the X, Y, and Z separate. Now the way that we are going to move it is simply, if you look at the cube, the camera is facing in the X direction. This right here is currently the X direction. So it is the Y direction that we will be moving through, okay? Since we are moving through the Y direction, we want to get the current X, Y, and Z position of the character, and then we shall make adjustments only of the Y direction. So let's start with that. Start off with the basic get actor location node. So get actor location. So now that we have the actor location, I'm simply going to right click on it and split it up. Now that we have split it, we have direct access to the X, Y, and Z positions. So I'll get the X and I'll set it up there so that it doesn't change X position. I'll get the Z and put it here so it doesn't change the Z. And then as far as the Y is where we want to change location. So just drag it out, click on add, basically type out add, and that's going to add in an add node. And we want to add, since we are moving left, we want negative on Actually, I was going to say add negative 200. So what that's going to do is it's going to cause its relative location to reduce by 200. Let's look at what that looks like. So I'm going to press play. So now immediately I press the left movement. One moment. Oh yes, the component has not yet been selected, so it's not moving anything. So since the capsule component is the primary part of the object, we're going to get the capsule component, drag it in, and it is going to be the component that gets moved. Now let's try that again. So now every time it's going to move the capsule component 200 units to the left. Okay, and then it's done. That's fantastic. Now that that is done, let's quickly add a quick breakpoint to it because we don't want it to be pressed multiple times all at once. Click down. Let's create a do once, a basic do once, and we want it to only reset after it's completed. Now let's see what it feels like to press that. So now I've pressed left and it has stopped. Even though I keep pressing left, it's not continuing. Then it's reset. I press left. Nice. So that is good. That makes the inputs much smoother and better to interact with. And now to do the same thing for moving right, we basically need to copy everything over. So we shall start with the basics. We'll start with the basic do once, and we'll add in the smoothness of movement earlier. So the completed is what does the reset. And then I'll simply copy the move component to node with Control C, paste this over here, and then connect that to the move. That's good. And then get the X value, connect it here, get the Z value, connect it here, and then get the Y value, drag it in. But this time we're going to add in another add. But instead of adding a negative 200 like we did here, okay, we're going to just add in a positive, okay, of 200. And then we'll drag that to the target relative location. And then from the capsule component, that's what we want to move. I'll drag that in as the component. Now, this is all the code used for our movement. So let's see if it works correctly. Press play. Left, correct, right, correct. So now we have set up left and right movement. Now, simply going to add in a quick, copy this, a quick comment before moving forward. So connect that, good comment, and then increase the size of the comment by pinching it from the corners. And we're going to call this left plus right movement handling. Okay, so left plus right movement handling. Now at this point, all the basics of movement are managed apart from slide, but we'll get to the slide a little later. So right now, we can move left and we can move right. And if I go back in and I reconnect the movement input node, all right, compile and hit play. So it's moving forward, it moves left and right, and it has a jump. That is excellent. Now in the next video, we're going to put in the code for putting the limits on the left and right movement. Let's move forward. All right, so at this point, our character is able to move left and move right and jump up but it can do so in an unlimited way. So what we want to do is to limit movement to 3 lanes. Now, going back to the initial plan of the infinite runner, there are 3 lanes. There is lane 1, lane 2, and lane 3. Using that planning and design is how we're going to organize how the lanes are set up. Now, let's jump into Unreal Engine and set that up. Now, inside of Unreal Engine, we have our event begin play where we set up the controls. We have the event tick that is currently adding in a directional input to move the character forward. And we have jump handling, which handles the jump. And we have the left-right movement handling. Now, what we are going to do is we are going to set up a limitation to the left-right movement handling. We'll set it up here, which is going to prevent the movement from happening if the player is at the limits. Now, the thinking behind it is pretty simple. We are going to set up a variable that is going to be an integer. Basically, it will hold whole numbers of information that will go from 1 to 3, and its default is going to be position 2. When you move to the left, what it does is it's going to get that 2, subtract 1, and it's going to become 1. Now at 1, any inputs won't affect it if it's trying to move to the left. However, if you move to the right, you will be allowed. Then if you try to move to the right again, as before, we will add 1, which is going to make it 3. And then at this point, we shall stop the player from moving to the right. All right, that's the general theory. Let's put it into practice. Let's start by creating the variable. Now, to create the variable, we simply go over to variables. We will add a variable. Now, it's currently set to Boolean. Let's adjust that and set it up as an integer, basically a whole number. I'm double clicking it and pressing F2 to change the name. And now I'm going to call this lane position. All right. And zoom out and quickly hit compile. Once we have compiled after making a variable, if you select that variable, you'll notice on the right-hand side of details, it's going to show some data. So we have lane position, which is an integer, and there's a light description. I rarely describe variables when I am working on my own projects because I believe the name should describe it. But if you're working on a large team, it's always good to describe it. Like this one would be stores information on position of the main character in the lane, and then I would type something else like we use this to limit left and right movement. So now that description of the variable is there for other team members, but the name should make enough sense by itself. Now, when you come down, is it instance editable? No need to make that instance editable currently. Now, we simply go to the default value, and we're going to set its default value to 2. Just understand the general logic so that you can easily make adjustments. Some people would rather start from 0 and call the lane 0, 1, and 2. But for simplicity, I'm going to call the lanes 1, 2, and 3, 2 being in the middle. Now, with those variables set up, we can now start using and implementing the variables. Keep in mind, we know for a fact that the variable starts being a 2. That's its starting value. Okay. Now that we know that, we can head over to the code which manages the movement, and we have input action move right? Now, what we are going to do is something really, really easy to understand. For starters, let's extend that comment box. and that component move to, we're going to move it forward. Okay. Now we are going to create what is called a branch. Now what that branch does is it's going to cause there to be an if else statement that determines the flow of code. I'm sure you already understand what this is going to look like. Let me push this forward a bit. The next thing we are going to do is, now that we have a branch set up, it has a condition. Now, right now, it's by default, it's set to condition on. Let me show you what that looks like. So let's, from the debug menu, select the player or whatever your blueprint is called, and then hit play. So now notice when I move right, it's showing the code firing off that the player is moving to. Rather, when I move left, it's showing the player moving to the left. However, if I were to set the condition to disabled, now when I try to move left, the code flow stops there. Okay, now that we have that dialed in, we need to decide what the condition is. And if the condition is true, the player can move to the left. And this is a simple logic. So let's start with the lane position. So we'll get the lane position and put it in here. And we'll say, hey, let's get the lane position. All right. And then we want to look for if it is less than. Okay. So if it is less than, so if the lane position is less than 2, because it's looking at the number, then you cannot move to the left. So let's link this up and set it up over here. Okay, so basically if the lane position is less than 2, then the character cannot move to the left. Now, we don't have any code altering the lane position value. So if we were to hit play now, essentially, it's not going to work at all. The reason why is because it's currently checking to say, hey, is the lane position less than 2? And right now, what it is false. In other words, the lane position is 2. So right now, coming out of the branch node as true, it's not going to move. Okay. However, if we break that link and now we connect from false to move to, okay, and we hit play, now notice we can move to the left. You can, this is the beauty of blueprints, you can see the flow of code. So now that we have this working, rather not yet working as intended, I just wanted to show you how it works. Now we want to set it up so that every time the player moves to the left, lane position reduces by 1, and every time the player moves to the right, lane position increases by 1. So let's head over to after movement, because remember, it is the movement that will change the lane position. So after the move component 2, right, what we really want, we'll get lane position. We'll say, hey, set lane position. And we will be setting lane position to lane position. And then we type subtract. And we are subtracting 1 because we're moving to the left. We'll attach that. And then we'll attach it from here on completed. Okay. So every time the player moves to the left, lane position is subtracted by 1. Okay. So let's quickly save that, zoom out, compile, and now let's play. So now I'm not moving to the left anymore. Okay. So I hope the logic is making sense to you. because it starts off in lane position 2. When we move to the left now, lane position is 1, so it is refusing to move further to the left. So this is really cool. We have the first bit dialed in, and our branch code is working correctly. Now that we have that working correctly, let's do the same thing for moving to the right. Let's quickly move this ahead, and then we'll do the same thing here. From the input action move right, and after the do once, simply branch it out and then look for a branch. Now that the branch is set up, we need to set up some conditions. So I'll get the lane position, and then what we want to look for is greater. Now we want to check for if lane position is greater than 2. Okay, basically if lane position is 3. So now that we have lane position, a check for if lane position is greater than 2, that's going to be our condition. Now remember, if lane condition is greater than 2, we want you to do nothing. So we need to break the true and drag out the false. And then when we are done with that, right after the move component 2, let's get the lane position, but this time we will be setting the lane position, and then we will get the lane position. Okay, and then we will simply add, and we will add 1. Every time you move to the right, the lane position gets a 1 added to it, and then drag that to the lane position. Sure, this is neat and organized. Now that this is all set up, let's zoom out and compile and hit play to test out our code. So I move to the right, it allows me to move, but if I am pressing right again, it's not working. Let me zoom out a bit so you can see the nodes info. I've hit play. I move to the right once, it moves. I keep trying to move to the right, it doesn't. Nice. Now, let's test out both left and right movement. Right, right limit. Left, nice. And just like that, you now have the ability to limit left and right lane movement. I hope that everything I've taught today has been easily understood. Please, if nothing is, if anything isn't working as intended, go back and rewatch the video. I've done my best to be really clear. If everything is working, let's move on to the next lesson. All right, so now that we have our character that is limited in how it moves left and right, now we're going to set up an infinite spawning platform, because right now we have our limits on moving left and right. However, notice that just as we are starting to move forward, the platform we are on is done. Okay, so we want to have some infinite spawning platform. Now, the very first thing that we're going to do, and I recommend, is we need to start with some general theory of what infinite spawning is. Okay, so this is the general thinking. Let's assume we're looking at the player character from the side view. So the player is constantly moving forward in that direction. Now, right now, when the player moves forward, they are done and they fall off the map, okay? But what we really want is when the player is spawned in, at around here, a new platform is spawned in front so that the player can continue moving on it. And then around here, the player, another platform is spawned, and then the player can keep moving forward. That's the general thinking we are going to use to get this done. Now, in order for that to happen, we are going to need two things. The first thing is we're going to need a platform blueprint, and that's where we're going to store all the code for causing it to spawn more copies of itself. And then we're going to need a hit detection for when to spawn in. Now, that hit detection is just going to be something as simple as it's kind of like an invisible thin little barrier. The player can't see it, right? The player isn't going to be able to see it. But that little blue wall is going to be the thing that the moment the player touches it, then boom, another copy of the platform is going to be spawned in. And we're going to set it up so that as the player, let's say the player starts out right over here, right? So the player comes, hits it, and then it's going to spawn in another platform, okay? The moment the player is around here, okay, it's going to despawn this platform. Now, there are lots of ways to do it, but in the spirit of optimization, we'll set it up so that on the first platform, okay, there's going to be two hit detection areas. There's the first hit detection that causes it to spawn the second platform, and then there'll be a second one that's just after it that causes it to completely despawn. That's how we are going to set it up um, in order to have our infinite spawning platform. Now let's go into the code and see how we can make this happen. All right, so now that we have all the theory covered, let's actually create the infinite spawning platform. Now, just to start things off, I'm going to right click on this platform which we start with, right? I've right clicked it and then I'm going to press delete. But before I press delete, let me check out the details real quick. So we know that this is a platform and we know that it is set up to have a scale of 8, 8, and 8. So it probably started out as a square and its location is minus 0.5. So we want to keep that minus 0.5 and that scaling of 8. So to do that, just going to keep that in mind, select that and delete. So this time if we were to press play, the player is basically just kind of falling in empty space, right? I'll click on the outliner and double click on the player start again. All right. Now I have hit Control and Spacebar, and inside of content, let's create a brand new folder. And that folder, I'm going to call it, let me call this objects. Okay. And inside of objects, I'm going to create another new folder and I'm going to call this platform. Okay, so platforms. Now inside of the platforms folder, just to keep everything organized, we are going to create a new blueprint class and we're going to call it an actor. Okay, and we're going to call this, let's call this base platform. Okay, and double click on the base platform. So now inside of Unreal Engine, we have an empty blueprint which we can utilize to great effect. The first thing we're going to do is we're going to add in a plane. So as you can see, we've added in a plane into Unreal Engine, okay? And that plane's location is currently set to 0, 0 and everything. And this basic plane is going to be good enough to start. Let's add it into the world and have a look at what it looks like. Let me drag this back into the main window, hit compile. And now I'm going to get this base platform, drop it in, and as far as details, I'm going to set its location to minus 0.5. The reason why is that's where it was before. Okay, that's not going to work. Let me first put this at 0 and 0 and everything. So yes, let's see if the player will stand on it. Nice. So the player is currently able to simply stand on that platform. Okay. Now that we have that tiny little platform, let's actually give it some actual size. So let's go back to base platform. Let's see, based off this position, we need to increase its X position. So I'll select it. I will go to scale, and its X scale, I'm going to increase that to something like 20. Okay, so that's its scale along the X axis. Let's see if this matches correctly. Good. So on the X axis, it's about 20 units. That's good. Now that we have the knowledge that it scales to around there on the X axis, let's increase that a bit further. I think we can increase that to something like 100 on the X axis. That gives our character enough runway. Now let's increase its width. Now increasing its width this time around is increasing its y-axis, and we'll increase that to, let's try to make sure we increase its y-axis to just outside of where the player can move left and right. So let's start with 30. Okay. Now at 30, if we go back to the map, yeah, it's a bit too wide. Let's drop it down a bit. Let's try 10 and see how wide that is. Yes, 10 is about perfect. Because as you can see, I'm moving left, it stops around there. I'm moving right, it stops around there. Actually, let me drop it a bit to be a bit smaller so we're even closer to the edges. I've brought it to 7. 7 is just about perfect. We can just about see the edge, and this is very good. All right, so we have this base platform. It runs from all the way over here to all the way over there, and that's cool, and which means that we now have the base, but you can notice that the color is white, and I'm sure that's not something which is really nice on the eyes. And if we're making adjustments, we'd like it to be a different color so we can see it a little bit better. Now, making it a different color is really simple. Control spacebar to open it up. I'm simply going to right click, and then what I want to look for is material. Yes, so we'll quickly create a new material, and we're going to call this base platform material. Okay, and then we can double click on that. That basically opens up the material editor, and right now what we want to do is adjust the color of the base. So let me make it like yellowish, orangish, just to give it a different color. We're not doing anything so advanced. I'll go back into the base platform, and then instead of setting up the basic shape material on the plane, okay, if we go and we drop down, we can see base platform material. Select that, and now it's going to have a different material. Let's make sure that this is properly applied. The base color. Yes, now it's properly applied. Hit play. Yeah, now at least it will make it easier to develop now that we have that more visible. Now that we have that, there are now 2 more elements we need to add. We need to add, let me open the plan. So what we need to add is we need to add 1 hitbox, which is to detect when the player has gone through the platform to spawn another version of itself around here. And then we need to add another hitbox, which is going to detect that the player has passed through here, and then it's going to cause this to self-destruct to save on RAM for optimization. Okay. Now to do that, we will go back to the base platform blueprint, and we need to decide on where we're going to place the hitbox. Okay. So we'll start by just going to add. And what we want is we want to add in not a static mesh. Let's go down. We want to add a yes, let's add a box collision. I think adding in the box collision about halfway is not too bad. Let me select the box. It's tied to the plane. And now let's increase its scale on the width. And then let's increase its, oh no, not on the X. Let's increase its scale on the height. Okay. Because we want it to guaranteed hit the player as long as, once again, nice, excellent. So let's scale it to about 2 on the width and about 10 on the height, just to be safe. Okay, make sure that it's guaranteed to hit the player. Okay, and as far as the collision, we'll select it and hit F2 to make a change to its name, and we will call this spawn collider. Okay, because when the player collides with it, it will spawn the next hitbox. That's cool. Now that we have the spawn collider, let me move forward slightly. I'm zooming out. I'm using WASD and my mouse buttons to move around. And now I will simply Control C, Control V to basically paste. Okay, so it's pasted and added in another box. Now select that box and I'm going to drag it way ahead over here. Okay, way ahead over here. And I'm going to call this box, okay? I'm going to rename it, and then I'm going to call this the spawn self collider, because when the player collides with it, it's going to despawn itself, which is very important. Now that we have that, let's start by getting the spawn collider to do its job. Now, to get it to do its job, now that we have it here, we shall head over to the event graph because we want to add in some logic. We'll come over here and now on the spawn collider, okay, we will simply add an event and the event will be on component hit or on component begin overlap. I personally like begin overlap. It tends to be much more reliable on its detection. So you can use that, but you can also use component hit. So we'll start with the basic on component begin overlap, which means the moment anything that it's set to interact with touches it, it's going to fire off all the code that is here. Now we're going to start with a really simple thing, which is going to be print a string, and we are going to call out and print out, hey, over, and we'll call it overlap, right? That's all we're going to do to make sure that it's working effectively. I'm going to hit compile and let the ice cream truck pass by my window. Okay, it's gone. After hitting compile, I'm going into the runner map. Now you'll notice on the runner map, right now it is set so that this collision is right over here, which is not what we want. So to make that better, I am selecting the entire, this entire blueprint of the platform, and I'm going to move it forward. Okay. Let me go into details to really see how far ahead I'm moving it. I'm moving it forward exactly 4,000 units. Okay. So you can see on the x-axis, I'm moving it forward 4,000 units because we want to check for the detection of this. But it's good to see that our hitboxes are showing up correctly. Then hit play. Now what we are looking for is, and yes, there we are. It appeared, okay? You saw that the overlap appeared on the left area of the screen. Let me play that again, just so you can double confirm. You should see the print screen here when it has connected. Nice, overlap, good. So we know that that is working correctly. Now that we know that this is actually working correctly, this collider is working correctly, we can now add in some nice code. So let's delete the print string. We already know that's working correctly. Collision working properly. We can delete all of that comment, and we now want to have it spawn in. But keep in mind, to spawn somewhere, you really want to have the spawn position locked in. Now we know that the distance from around here to the end is 5,000 units. So let's quickly go and add in a position. Okay, we'll be using a point arrow for this, and we're going to call this the spawn position. Okay, now this arrow spawn position is now over here inside of the viewport, and we want to just drag it forward. Okay, just drag it forward over here. Now you'll notice all I have to do is inside of its position set it to 5,000, and I think that's pretty much good enough. Okay, so that's exactly right over there. So we'll be using that spawn position as to where to spawn the next platform. So if we go back into the event graph now, inside here we have our own component begin overlap spawn collider ready to rock. So the next thing we want to do is we want to specify which actor it's going to collide with. So we're going to drag out from the other actor, and we're going to type player, and it's going to say, hey, cast to player. So it's going to be looking for the overlap with the player. Now, that is based off the fact that our player character is simply called player, but that can adjust its name depending on what you call the player blueprint. All right, moving on. Now that we've set it to cast to player, now let's drag it out, and we want to ask it to spawn in an actor, which is going to be itself. So it's spawning in actor from class, but the class is going to be base platform. Now, if we just have this set up as is, okay, save and compile, okay, notice we are going to get an error. And the reason why is because we've not told it where to spawn. We've said spawn this in, but we haven't specified where. So to specify where, let's quickly split this up as a structure pin. And now I've not given it any specific location. Now with that, if you compile and you try to run this, okay, it's about to collide. Oh my goodness, it's taking like 10 yards. Okay, let me press F8. Oh, okay. F8, by the way, is going to cause you to come out. So that means that this did not function as intended. F8. Yeah, it totally passed through the collision and didn't do anything. Fundamentally, this is not doing anything proper yet. So we want to actually decide on an exact spawn location so that it can spawn in properly. So we're going to get the spawn position. Okay, I'm going to drag it in over here, and then we want to get world location. So we are getting the world location, and then we'll link its world location to the spawn transform of location. Okay, drag this out over here, and with just that, let's see how this works in game. So in game, I'm going to hit play. I'm hitting F8 and zooming out just so that we can see it. Okay, so you can see the platform was created there. Let's see if it works correctly for the next platform. Nice. Now it keeps spawning platforms, but we have a lot of platform in the back that is not despawned. So we're going to now work on the despawn. So now that we have the spawning working correctly, we now need to work on the despawning. But before we do that, let's quickly comment properly. Now we're going to just, of course, hit C, and we're going to call this spawn the next platform. Okay, just making sure to keep our blueprints organized and increase that. And of course, I personally prefer to have it totally black and set it up as just a comment, not group movement. So now we have this code that basically keeps the platforms spawning in. That is very good. Now we want to despawn. Let me first select the comment with Control C. Okay, that's copied. Let me paste the comment box for organization and despawn previous platform. Okay, that's the text I'm using. Now with that, I'm going to select on the despawn self collider, add event, and on component begin overlap. Okay, put that in here. And I'm going to go through basically the same process. The other actor, I'm going to cast to the player. Now that that is cast to the player, drag this forward. All we want it to do is to destroy itself. And we've just typed in destroy actor to get the destroy actor node. And then we are saying, hey, just destroy yourself. Now, let me quickly compile. Now that we have done that, hit play. I'm pressing F8 to come out so that it spawn the next play. We're looking for the despawn. I'm not seeing the despawn. Okay, it has despawned. It moves forward. Wait for it. It has spawned in. Okay, it's moving. Despawn. Yes, now we have a relatively optimized infinite runner running. So the character moves forward and despawns the platforms in the back as they are spawning the platforms. Let's look at it one more time and then we move forward. Okay, so it's spawning everything in front, despawning everything in the back. Nice. This is perfect. All right, so now just to cover everything we have for our infinite runner, we have a player character that can move left and right and jump. We haven't added in the slide just yet. And then we have a platform that can basically spawn in infinitely, okay, because it spawns in front infinitely, and it's optimized so that once the player passes a certain amount of distance ahead, it despawns the platform in the back. Okay, that is very, very good. And now we are going to set up the different obstacles that the player is going to need to dodge when they are here in the platformer. And then we are going to set up a slide so that the player can slide under certain obstacles. Let's go in the next video. So now that we have everything set up so that we have this large platform that keeps spawning in continuously, we know that from here is when it causes the next one to spawn, and then around here on that next hitbox, it despawns the one that is over here. That's pretty fantastic. Now we are going to go on and we are going to add in the different obstacles and have them spawn in. Okay, now to have the obstacles spawn in, we need to first start off with some general planning. And planning it out, we're going back to the drawing board. Now we know for a fact that the player is going to start over here, and then as they keep moving, they'll hit one collider, which causes the next platform to spawn in, and then later another one to despawn. But what we want to do is to set it up so right after the player hits this first one, it's going to cause there to spawn in a lot of, when it spawns in the next lane, it should also allow it to spawn in with all the different obstacles. Let me clarify what that means. Now imagine for one moment that this is the player character on the platform, and this here is the platform that we have just spawned in. Now we need to set up the different possible places where a certain object that can block the player's progress spawns in. So let's say that that single white circle is a place where an object can spawn in. We want to set it up so that there are multiple different possible places where an object might spawn in. Now, since our player character can move right and move left one space, one lane, we want to make sure that across the 3 lanes there is a place where an object can spawn in to interrupt the player character and force them to move. Now, there's going to be way more than just 3 places where an object could spawn in. There are going to be many that can be used. Now, this is really tight spacing. So when we go in, the spacing is going to look more like this. So we'll set it up so that there's going to be enough space such the player comes, something spawns in one of those 3 positions, and then after the player avoids it, something spawns in one of these 3, and so on and so forth. That's the general theory. Now let's move in and actually set it up inside of Unreal Engine. All right, so now that we have the general plan, we are back inside of Unreal Engine, and of course, go to the base platform blueprint, okay? Now inside of the base platform, make sure to look for the node known as event begin play. This node fires off the moment that an object is spawned into Unreal Engine. So once our platform is spawned in, we then want it to spawn in all the different obstacles. So with that in mind, we're going to drag out from event begin play, and we're going to create a simple print string node. And inside of that, we are simply going to type spawn in obstacles. We're going to use this to do some quick testing to make sure event begin play is working as intended. Now, we're going to have a lot of code, so let's create the comment. I'll select this node and then press C. So now it lets me type in a comment, and I'm going to call this spawn in obstacles. All right. Now, this node right here, rather inside of this comment box, is going to be all the code for spawning in obstacles. We'll get back to this. First, let's quickly test if the string spawn in obstacles is coming out correctly. So press play. The first one, yes, moves forward, boom. So it is working in correctly because right after the player character hits that collider and spawns in the next platform, it fires off. That's pretty good. Let's go back in, make sure to compile, and now we need to set up the position where we can spawn in the obstacles. So if we check inside of the viewport, we are able to see that the platform is here, and if we look, we have an arrow called spawn position. Now, that arrow is where the spawning in of the next platform happens, which is good. What we are going to do is we'll simply click it, Control C and Control V to create a second one. Now, just for organization, I'm going to change the spawn position name to spawn new platform position, and the name of the next arrow, I'm going to call it spawn obstacle -1, because it's going to hold the first place where we are spawning in obstacles. So I've clicked on it, and instead of moving it by hand, I can simply go over to its location in properties, on the x-axis and move it back. Now I'm going to make it negative 5,000, since I know that that's going to set it up to be at the very, very back of the platform. So it's right over here at the back. That is good, and it's at the beginning. Now that we have this set up, so we have the spawn obstacle -1 set up, what we're going to do, let's compile and then go back into the event graph. So let's set it up so that right after it prints out that string, it spawns in a single obstacle. Now, to do so, let's create the very first obstacle. You're going to press, of course, Control and Space Bar to lift this up. And we have to go into the folder of objects, platforms. Let's create a brand new folder, and let's call this folder obstacles, because it's going to contain all of the obstacles that we make. Now inside, we want to add in a new blueprint class, and the type of class, we want it to be a blueprint actor. And this actor, we are simply going to call it obstacle dash type dash 1. These are simple names to start off with. So our obstacle dash type 1 is going to be there as a blueprint. Now we'll double click on it and it opens up a whole new window. Let me drag this into our main window so I don't need to keep flipping through windows. So this is our obstacle type 1, and what we are going to do is we are simply going to add a component to it. And the component we are going to add is very simple. It's going to be a simple cube. Now that this cube is added in, as you can see, we don't want the cube to be this with half of it underneath the ground. So what we're going to do is we're going to change the cube's position to be right around the nice. So at about, hold on. Yes, at exactly 50 units on the z-axis, the cube is right up there above the ground, because we don't want it to be spawning beneath the ground. So it's slightly raised up. But our cube needs a new material, which we are going to use to give it a different color. So Control Spacebar, we'll go back into objects, and notice in platforms, we created a new platform. Rather, we created a new material. So inside of obstacles, we'll simply right click, and then we want to create a new material, simply typing that in. So we've created that material, and we're going to call it obstacle material. Okay, and then double click on that material. And now we're going to keep it really simple. We're just going to select the base color, and since it's the thing that's going to be damaging the player, let's set it up to be the color red. Basic simple color selection. Man, that is okay. I'm going to need to do this manually. Let me drop the greens to 0. I want it to just be purely red, and hit OK. And now that's the material, and then hit apply. It's applying the changes to the material, and then it's done. And now we go back to obstacle type 1, click on the cube, okay, and then click on under materials, click on that, and then select the obstacle material, just so that as we're building out the prototype, we're able to see what's going on. And now, with all of that, let's make sure everything is compiled and ready to use. Compile. All right, now we'll select the base platform, and we want to select spawn position, rather spawn obstacle -1. So we have spawn obstacle -1. We're going to drag it out over here because we're going to be getting the position from it. And then very similar to what we do to spawning in the platform, we'll drag that out, and we want to spawn actor from class. And then we will select the class is called obstacle type 1. So we select that as our class. And now it's looking for its position. We drag this here. I'm right clicking on that split structure pin, and then I'm going to drag this out and select a get world location. Okay, so I want to get the world location of the spawn obstacle 1 arrow. Drag this over here and then connect it as the transform location. Okay, now with just that, let's quickly compile and check out if this is working correctly in game. So to do that, we'll go back into the map, and I'm going to press F8 after hitting play so that we can get a better view. I've pressed play, F8. Let's see, does it spawn in? Oh, it spawns in right over here. This is a bit far back, but you can see it also spawned it in right around here at the start. So this is a good position for it to spawn. And as you can see, the player basically ran into it, which is not too bad, not too bad at all. Now let me hit pause. So let's see obstacle type 1. So this is working correctly. We go back to the base platform code, and this is working correctly. So now we have figured out, hey, this is the very first place whereby it can spawn in an obstacle. Next, let's figure out how to make sure that it can spawn in the obstacle in different positions. Let's go. Okay, so we're now going to go in and talk about the 3 different obstacle types and how we're going to spawn them in. We're going to have one obstacle type which is really low to the ground that the player has to jump over. We're going to spawn another obstacle type which is basically full coverage. So the only way for the player to dodge it is to move left or right. And then we'll spawn another which is just a high obstacle type. However, for the player to dodge this, the player has to slide under it. I'm going to keep it that simple. Let's go into Unreal Engine. Now, currently, when we look inside of Unreal, we've created a single obstacle type, and we called it obstacle type 1, right over there, okay? Now, what we want, so let's play this, is it's a single obstacle type, it's only on the ground. But what we truly want is to have that variety of one that's up high, another that's down low, you have to jump over, and another that's full coverage, forcing the player to move left and right. Let me double click on the player to bring it back. So let's go back in and have a look at the code and make adjustments. For starters, this is obstacle type 1, and it's the only one that exists right now. To keep this simple, inside the event graph, all that it does is after a 30-second delay, it destroys itself. So what we're going to do, I'm going to hit Control Spacebar. I'm going to head over to Objects, Obstacles, and right now there is only one type called obstacle type 1. I'm just going to get this, and then I'm going to copy it and paste it here. Okay, so essentially you just want to come over here and select duplicate, which is Control D, and I'll duplicate again. And Unreal Engine does a good job of automatically changing the names. So now we have obstacle type 1, obstacle type 2, and obstacle type 3. Then just for safety, I'm going to come over here and I'm going to hit save all. So Unreal Engine saves all of my changes. So now I have obstacle type 1, 2, and 3. So let's go into the code and have a look at 2. Let me put this back into the main window and then double click on 3. So now I have access to make changes to obstacle type 1, 2, and 3. So let's leave 1 as this basic obstacle that you have to jump over. Okay, so we look inside of Unreal Engine. 1 is this basic type over here. We're going to make some changes to it, but let's consider 1 to be the one you jump over. 2 is going to be the one that you have to move to the left or right. And 3 is the one you have to slide under. Let's get into that. Let's go into base platform, okay, which is our base platform that spawns everything. And there is a macro here. So it simply states, hey, spawn obstacle, that's the position. Let's go into the macro. And here we go into the spawn position function. All of these right now spawn an actor obstacle type 1. Okay, no matter which direction it is, notice the spawn actor is spawn obstacle type 1. And we want to change this up. The way that we're going to change this up is we're going to create another little function within here. So to make that function, the first thing is we'll get this. We'll just copy this node by itself and put it in here. And now that we have this node that says spawn obstacle type 1, we'll simply copy and paste it. Now we'll change it to obstacle type 2. So now we have two nodes. We have one node, spawn obstacle type 1, another spawn obstacle type 2, and then we have another, copy and paste this, that is obstacle type 3. So essentially, this can spawn either obstacle type 2 or 3 or 1. Now that we have this over here, bring these in together, let me zoom out. So we are going to gather these 3 over here, and then I'm going to right click and then collapse to function. Now, one moment. We need to add in more code in order to spawn this in. So let me zoom in and add the code in here before we collapse it into a function. So what we are going to do, drag this out over here. We're going to do the exact same thing we did over here. So we shall simply type in random, okay? And we want a random int. And we want a random integer in range. And the minimum is 1. And the maximum is going to be 3, okay? So it will always call out a integer, either 1, 2, or 3. Now that we have that, we're going to have a switch on int. Then we're going to drag out the return value, and then we will have 3 different pins. Now, if the value from the random integer is 1, we'll drag that out to obstacle type 1. Zoom out a bit. If the value is 2, we'll drag that out to obstacle type 2. And if the value is 3, of course, we'll drag from obstacle type 3 and we'll drag it into here, okay? Now that we have these set up properly, we can make adjustments. So now that we have this, okay, we have this part of the code here that switches the position based off a random number to be to the left, to the middle lane, or to the right lane. Now we're going to adjust all of this and change it up so that it leads into this function. So let's quickly test and see. I'm going to drag out over all of the spawn in nodes and collapse to function. So there it is, we have a new function. I'm going to select it over here, and I'm going to call this spawn, not position, obstacle dash type. So that's what this function is called. It is called the spawn obstacle type. Okay. Now that we have a function which can basically spawn in an obstacle type, let's make adjustments to it. So double clicking on the function, we know for a fact we want this to bring in the position nodes rather, the position links. This is going to make sense in a second. Okay, let me move these over here. Come back over here. Now, when it comes to the obstacle type, we want to add in some input. And this input is going to be, it's not going to be a Boolean. It's going to be, let's see, is it a vector? No, we want to have it be a float. Yes, we want to have 3 floats actually. So we'll have this. We'll add in 2 more float inputs. And we'll call this first one X. We'll call the second one Y. And we'll call the third one Z. So we're going to have these inputs of X, Y, and Z as inputs. Now let me bring these nodes closer of the spawning in of the obstacles. And I'm certain you know what this is going to mean. So what we are going to do is we're going to drag the X from the input into the spawn location X over there, spawn location Y, and spawn location Z. Okay? And then we'll do the same thing for the obstacle type 2. We'll connect the X, Y, and Z connections over there. That's cool. And then we'll do the same thing for the final spawn location. Okay? Which is rather not spawn location, the obstacle type 3. We'll connect that over there. We'll connect this over here as well. For the Y. Cool. And then we'll connect this. Moving it over here for the Z. Now that we have all these set up, put this over here, put this over here, we are basically done with this function. So we have a basic function called spawn obstacle type that goes into a random switch on int from 1 to 3 that will choose to spawn in obstacle type 1, 2, or obstacle type 3. That's fine. Now that we have that, we can close this function. Okay. This macro is not what I want. So let's go into the spawn position, should be over here. Spawn position function. Okay. Now notice the spawn obstacle type is now connected over here. Okay. So now that we have the spawn obstacle type connected over here, let's drag this out over here and leave it here. Now that we're done with that, we can come over to this, and then all that I'm going to do is I'm going to delete this, delete that, and delete that. So we have deleted all of those nodes which were initially spawning in obstacle 1 every single time. So now we have a simple challenge. How do we make sure that everything that we, how do I say this? All the nodes moving forward connect in with the right positioning. Now that's going to actually be pretty simple. The way that we're going to do that is we're going to set it up so that each and every one of these switches goes to a set of X, Y, and Z. Let me elaborate. We're going to create a variable, okay, over here. And in the variable, we're going to create a vector, okay? It's going to be a vector 3D. And we're going to call this obstacle dash position. Okay, that's the vector. Now we'll drag out obstacle-position over here, and we're going to set up a set node. Okay. Now that we have the set node, drag this out. I want to set this up to split it up. Okay. So we are basically setting obstacle position. Okay. Now that we have it, we're going to set up 3 of these. Copy and paste. We'll have this, and then copy and paste. We'll have this over here. Okay. Now that we have these 3 organized and set up, we're going to say, hey, if 1 is the random number, we have it set up there. If 2, it links to the second one. And if the random number is 3, it links to the third one. So it will randomly choose between those 3 positions. But no matter what, all of those 3 positions will feed into the spawn obstacle type function over there, which is cool. Now that we have that, come back over here. The next thing we want to do is let's split this up. Split this up. And split this up. Those of you who have spent some time in Unreal Engine can already see a simpler way to do this, but we'll keep using the more basic way to start, just so you understand clearly what's going on. Now we'll connect all those splits. Actually, no, this will not work correctly. Let's revert. We're going to make a big change moving forward, but that doesn't matter for now. So now that we are there, let's adjust the inputs. So we want to input the X correctly to all of these different sets, and it should function perfectly. Okay. And then we want to connect the Z input correctly to all of the different sets for the obstacle position. Excellent. Now we need to connect the upper over here. Okay, if one is the correct one on the Y, we need to connect the Y directly to the second position, and then we'll use the minus 200 units for the third Y position. Now that we've set these up correctly, we now have this variable that is coming out called obstacle position. With that, first of all, let's quickly save and compile. We go into obstacle type, and we're going to make another change to the inputs. So under the inputs, before we're pulling out 3 floats, but let's remove those 3 floats. And instead, what we need to do, we'll actually leave out any of these inputs. We don't need those inputs actually. What we're going to do is we're going to come over here. We'll recombine the structure pin of the transform location on all of these nodes. After we've recombined it, we'll simply get obstacle position, and we'll connect it to the transform position there. Connect it to the transform position there as well. And then rather transform location, and connect it to the transform location for the third node, which it looks a bit cleaner. Let's be real, it looks quite clean. So now that's all we need to do inside of the spawn obstacle type function. Now that we are done, we can go back into the spawn position, and as we can see, it should all be working correctly. Now, without making any other changes, we can go into game and test out and see how it works. I've hit play. So right now it's working basically the same, but the only reason it's working the same is because all of the current spawns are the same, right? It's still spawning in the exact same obstacle type, but we have the fundamental code working correctly and it is sound. So in the next video, let's make adjustments to the different obstacle types.